Again, welcome to Computer Architectural course. This lecture covers the basic concept of computer architecture, and the lecture slides is based on Computer Organization and Architectural textbook by William Stallings. So again, our main objective is to explain the general function of a digital computer. Now, a decision is often made between computer architecture and computer organization. A computer architecture refers to those attributes of a system visible to a programmer, or we can put it another way, those attributes that have a direct impact on the logical execution of a computer. Now, a term that is often used interchangeable with computer architecture is instruction set architecture, ISA. Now, instruction set architecture defines the instructions formats, instruction opcodes, registers, instruction, and data memory. Now, the effect of executing instructions on the registers and also a memory, and also an algorithm for controlling the instruction execution. In our future lectures, we are going to discuss the concept of, again, ISA, the instruction set architecture. Now, computer organization normally refers to the operational units and their interconnection that realize the architectural specifications. So examples of a computer attributes include the instruction set, the number of bits used to represent various data types. Example can be numbers or characters. Also the input and output mechanism, and also techniques for addressing memory. So organizational attributes will include those hardware details transparent to the programmer, such as, again, the control signals, interfaces between the computer and peripherals, and also the memory technology used. So again, for example, it is an architectural design issue whether a computer will have a multiple instruction. Also, it is an organizational issue whether the instruction will be implemented by a special multiple unit or by a mechanism that makes repeated use of add units of the system. So the organizational decision, again, may be based on the anticipated frequency of use of the multiple instructions. Also the relative speed of the two approaches, and also the cost and physical size of the special multiple unit. Now, one of the prominent examples of both these phenomena is the IBM System 360 architecture. Again, this architecture was first introduced in 1970 and also included a number of models. A customer with a modest requirement could buy a cheaper, slower model, and if demand increased, later upgrade to a more expensive, faster model without having to abandon the software that had already been developed. Over the years, again, IBM has introduced many new models with improved technology to replace, again, the older models, offering the customer, again, greater speed, lower cost, or possible both. So the architecture has survived to this day as the architecture of IBM's mainframe product line. Now, a computer is a complex system. Also, contemporary computers contain millions of elementary electronic components. Now, the key is to recognize the hierarchical nature of most complex systems, including the computer. So the hierarchical system is a set of interrelated subsystems. Again, each of the later in turn, the hierarchical structure until we reach some lowest level of elementary subsystem. Now, the hierarchical nature of the complex system is essential to both their design and also their description. So the designer need only deal with a particular level of the system at a time. Again, the designer need only to deal with a particular level of the system at a time. Now, at each level, the system consists of a set of components and also interrelationships. Now, the behavior at each level will depend only on a simplified, abstracted characterization of the system at the next lower level. Now, at each level, the designer is concerned with the structure and also the function. Normally, the structure will be the way in which the components are interrelated. And also the function will be the operation of each individual component as part of the structure. Now, in terms of description, we have two choices, starting at the bottom and building up to complete description, or beginning with a top view and decomposing the system into its subparts. So a computer system will be described from the top down. Now we are going to begin with the major component of a computer and also describing their structure and function, and possibly proceed with the lower layers of the system. So now here we said there are four basic functions that a computer can perform: data processing, data storage, data movement, and also control. So normally data processing, here we can say that the data may take a wide variety of forms, and also the range of processing requirement is broad. However, we shall see that there are only a few fundamental methods or types of data processing, and we are going to discuss this again more in detail in the future lectures. Now, we also have the data storage. Here we say the computer must temporarily store at least data that are being processed by the CPU. So this can be in the main memory, or it can also be in a special memory called the registers or the cache. And also in the future lectures, we'll go details about memories. So that's, again, there's at least a short-term data storage function. Equally important, the computer performs a long-range data storage function. Files of data are stored on the computer for subsequent retrieval and also update. This can be in the hard drive, storage, different types of storage devices. Also, we have remote devices. Also, we have data movement. Here we say the computer's operating environment consists of devices that serve as other sources or destination of data. So when data are received from or delivered to a device that is directly connected to the computer, the process again is known as input and output, or I/O. And the device is referred to as a peripheral device. And we may discuss this more in details also. So when data are moved over longer distances to or from a remote device, and this process is known as, again, data communication. And the last one is the control. Now, within the computer, the control unit manages the computer resources and also orchestrates the performance of its function parts in response to those, again, functions. So again, in these lectures, we discuss the basic concept of first of all, what is a computer architecture and what is a computer organization, the difference between the two. And also we discuss, again, the function and the basic. Again, here we are talking about top level, the basic concept. So again, see you in the next lectures, and thank you.